Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapgood. Dear students, in the previous class we are solving some numericals on conduction heat transfer. Okay, we try to calculate the rate of heat transfer per unit area and total rate of heat transfer, and also we try to calculate the temperature gradient. Okay, come we'll move towards next numerical on conduction heat transfer. So that too Fourier's law of conduction heat transfer. Dear students, so I will read the problem first, then I will try to solve the numerical. So example 4, a plain wall, just a minute. Okay, a plain wall is 150 mm thick and its wall area is 4.5 meters square. If its conductivity is 9.35 watt per meter degree Celsius and surface temperatures are steady at 150 degree Celsius and 45 degree Celsius. Determine first one, heat flow across the plane wall. Second one, temperature gradient in the flow of direction. Dear students, he has given one problem. For that, what you have to do, you have to calculate the rate of heat transfer or heat flow, that is Q, then temperature gradient, that is dt by dx. Okay, so then how to solve this numerical? Dear students, we need to follow some steps. Okay, standard step. What are the standard step we need to follow? First, we need to draw the relevant schematic diagram for the particular problem. Then we need to list out the given data. Then what we have to do? We have to list out the important equations which are related to this particular problem. Then we will solve it step by step. Okay, now what I will do, dear students, what is telling now, we can see here. Okay, there is a plain wall. Yes, there is a plain wall. Okay, so dear students, understanding problem is very important. Okay, I can solve only limited numericals, but I will try to explain you the numerical thoroughly so that you can understand problem very well and you can solve such different problems. Okay, there is a plain wall. Okay, and that plain wall having an area, that area is equal to how much is telling, that area, it is having an area that is 4.5 meters square. Yes, that area we can represent here as a and it is having a thermal conductivity. The thermal conductivity I will mark here as a K, dear students. Okay, that how much he has given, 9.35 watt per meter degree Celsius he has given, and surface temperatures are steady. That means what, dear students, you can see here. So temperatures, we can see heat is moving in this fashion, so that is Q. We can say there are two temperature, one is 150 degree Celsius, another one is 45 degree Celsius. I will assume that this is high temperature region. I will mark here T1 and this side it will be T2. Heat is moving like this. Okay, so the T1 and T2 he has given 150 and 45 degree Celsius he has given for a particular plain wall. Then he is asking to calculate heat flow across the plain wall and temperature gradient. To do this, what I will do, dear students, I will take this, I will try to draw the front view of this wall. Okay, I will draw one more diagram. There I will represent thickness of the wall. This is nothing but what, thickness of the wall, that we can mark here as a dx, or you can take L or T up to you. Then area is A. The same thing what I will do, I will take this as a front view. Then I will draw the schematic diagram for that front view. Then I will give the notation for all. Okay, dear students, you can see here now. Now what I have done, I have taken a plain wall. This is a plain wall he has given. Okay, fine. The next, it is having any area. That area I will mark here as a. Okay, then I'll list out here parallelly. Okay, given data. Okay, given data. What all things he has given, that you can see here, dear students. Okay, so fine. Now it is a plain wall, 150 mm thickness. Yes, it is a 150 mm. 1 minute. Yes, it is 150 mm thickness. You can take dx. Okay, sorry, 1 minute. It is dx. Okay, so 150 mm thick, that I will take it here now, thickness of the plate, that is dx is equal to, or you can take L also, no problem, 150 mm he has given, so convert it into meter, you are going to get 0.15 meter. Okay, fine, that is the plain wall thickness. and it is having an area. That area I will mark here as A. So that A he has given, how much he has given, dear students, that we can list out. A is equal to, how much he has given, 4.5 meter square he has given. Directly he has given answer in terms of meter square. I will write it here meter square. And dear students, try to maintain the uniformity in the units. Here thickness he has given in millimeter, but area he has given in terms of meter square. But try to follow one. Okay, try to maintain the uniformity in the units. Okay, then that plate having thermal conductivity, that thermal conductivity we can mark as a K. Then that K also he has given. How much he has given? Thermal conductivity for the given material is 9.35 watt per meter degree Celsius he has given. Okay, fine. And he has given surface temperatures. What are the surface temperatures he has given, dear students? You can see here now. Okay, surface temperature he has given. Heat is moving in this direction. So here he has given T1 and here he has given T2. So T1 is equal to how much he has given, dear students? You can list out now. So therefore T1 he has given, 1 minute. So T1 is equal to how much he has given? 150 degree Celsius he has given. Then T2 is equal to how much he has given? That is 45 degree Celsius he has given, dear students. Okay, then you can see here now thermal conductivity also he has given in terms of degree Celsius. The temperature also he has given in degree Celsius. Then no need to convert that temperature from degree Celsius to Kelvin. Keep it as it is because I can maintain the uniformity in the units. Then next, what actually is asking now? To find what we have to find out. You have to find out what are the findings. So findings I will list out here now. So the first one is what? You need to calculate the heat flow. That means what? Rate of heat transfer is equal to how much? First finding. Second finding, you need to calculate the temperature gradient. That is dt by dx is equal to how much? This is the problem here. This is a problem analysis. Then I have drawn the diagram for a particular problem. Then I list out the given data. Then what I have to do? I need to solve this problem step by step. Then, dear students, wherever it is required, thermal resistance also you can draw. What is thermal resistance here now? You can see here now. Okay, the temperature at this point, what you can do? You can mark as a T1. Temperature at this point, you can mark here as a T2. Then here is the resistance. Then heat is moving in this direction. That heat we can mark here as a Q, dear students. Okay, so now this is the problem analysis. Then I will solve this numerical step by step. So what is first term? I need to calculate the heat transfer or heat flow. I need to calculate the heat flow. So to calculate that heat flow, what is the notation? That is Q. What is the equation now? I can calculate this heat flow with the help of Fourier's law of conduction. What is that equation? That is minus Ka into dt by dx, dear students. So now here, what is dt? dt is nothing but what? dt is equal to, that is actually final temperature minus initial temperature. You can see here now. So how we will take final temperature minus initial temperature. So what I can do here now, I will write it here. It is 1 minute. I can write this dt is equal to T1 minus T2. So therefore what I will do, I can neglect this term. Okay, so therefore how I can write now? Q is equal to, I can write it here now, Ka into what is dt? That is T1 minus T2. Okay, T1 minus T2 divided by what? Dx is there. You can take dx or L. It's up to you. Okay, fine. So now what is K value? That is 9.35 something else he has given. 9.35 he has given. Yes, I will write it here. 9.35 into what is area? Area is equal to how much he has given? 4.5 meter square he has given. Just, I'm sorry. 4.5 into what is T1? I will put it in terms of degree Celsius. How much? 150. 150 one side. The next is 45 degree Celsius. So here it is minus 45 divided by what is length? Length of the thickness of the plate. How much he has given? That is equal to 0.15 meter. That is equal to 0.15 meter. So I will write it here 0.15 0.15 meter. Then I will try to solve this numerical. Then how it is that you can see here, dear students. Okay, so now what I will do, 9.35 multiplied with 4.5 into what I can do, temperature difference, that is 150 minus 45 bracket close. Okay, then divided by 0.15. Then how much you are going to get, dear students? You can see SD. So Q is equal to what I can, 29452.5. Q is equal to 29452.5 watt. You got it. Okay, total rate of heat transfer. Okay, so now this is what total rate of heat transfer. You can write it, dear students. Now first finding is over. Total rate of heat transfer, that is capital Q, is equal to 29452 or 29.452 kilowatt also we can. This is what our first finding. The next second finding. What is second finding, dear students? We need to calculate the temperature gradient. Temperature gradient we need to calculate. Okay, temperature gradient is represented by what? dt by dx. So what I can do here, dear students, now you can see I will try to modify this Fourier's law of equation. How it will be then? Then Q into L divided by K into A is equal to dt by dx. Okay, so this is minus sign, you will leave it because I will take T1 minus T2. Hence you can neglect this dx or L, dq into dx or L divided by K into A. Then so therefore what I can do now, dt by dx is equal to, so what is that Q? What is the Q? Q value you know already, 29.452.5 multiplied with what is the thickness of the plate, that is dx or L, that is equal to 0.15 divided by what is K? K is equal to how much he has given? He has given 9.35 multiplied with what? Area how much he has given? He has given 4.5. Do simplification and how much you are going to get? Yes, I will do it here. Two 9,452.5 into 0.15 divided by 9.35 into 4.5. How much we are getting? That is 105. That is equal to dt by dx is equal to 105, dear students. Dear students, you can observe here I have done some small mistake here now. What is that mistake? You can see here now. One minute. Okay, what is that mistake? You can see here now. Just a minute. Okay, dear students, I have written by mistake, I have written wrong here now. What is that? dt by dx is nothing but I should not consider q l here. So hence it is wrong. Okay. So now dt by dx is equal to what? What actually? Q divided by ka. So what is the value of q? Q is equal to, already I know, 29452.5 divided by k into a. What is k into a? K we know already. That is what? 9.35 into 4.5. Okay, so now do simplification with help of calculator. How much you are going to get? So dear students, what I will do here now, 29452.5 divided by 9.35 into what I can do, 4.5. So how much I am going to get here now? 700. Yes, what I can do, this is not, okay, this is equal to how much? 700. That too, it is in degree Celsius, so I will write it degree Celsius, dx in meter. So then what I can do, dear students, dt by dx I can write like this, dt by dx is equal to minus 700 degrees Celsius per meter. Why so? Because temperature is going to decrease. So that decrease in temperature we can mark with a sign. That sign is negative, dear students. Hence what I can say, the final answer, that is change in, that is temperature gradient is 700 degrees Celsius per meter. This is how to solve the numerical, dear students. I hope you understood today's class. If you understood really, please do like and subscribe and share. If you want such a informative videos, you can download my app Anveshana Academy from your mobile Play Store. So you will get detailed all video lectures of heat and mass transfer. Thank you. We'll continue next class.